From a mechanical point of view, obviously the most important thing you'll ever do at this stage in development is just make the movement fit in. So we'd used our drawings. We were happy. We were happy with all the ridges and extrusions and how many micrometers away they were from the inside of the case and that kind of thing. But instead of sending that straight off a print and then learning off the back of that, we managed to get hold of a official piece of geometry. So I'm just going to make everything invisible apart from this. So this is an official ETA mesh, which is made exactly right. And this also helped us with the design. Actually, if there's enough requirement for it, I might put a link to this geometry in the video, which is bound to help other micros. I mean, even though we followed the drawings as closely as we could, when we dropped this in, we saw that they weren't exactly right. So this is a really useful resource for any micros looking to fit to the ETA format. Obviously, we're not using an ETA; we're using the Solita, this is the only accurate representation we could make for that movement format, if you like. We couldn't find one that said Solita on it. So apologies to anybody who spotted that it says ETA on it. We're not using an ETA. So this was the starting point for making everything fit together. I don't want to get too down and dirty with the technicalities, because I want to talk about the watch. Obviously, that's really important to us, and probably pretty important to you as well. So I'm going to go through a few of the design elements. So there's a few things going on here that will need explaining maybe a little bit. The first thing to notice is that we have a proprietary inner rehort. So because of the way that we wanted to do this, and we want the thing to be heavy, I think it's kind of important, not stupid heavy. And for those of you who know how we're building our watch, we're using HY80, recycled HY80 steel, which is a little less dense than 316L stainless steel. So it would be lighter. So this actually helps us offset. We didn't want the thing to feel insubstantial. So having the extra bit of metal here helps us to offset that slight loss in density. And also you'll notice, because of the unique quarter markers that we have in the design, is that we've drilled the rehort as well. That may have been done before. I don't know. But as far as I'm aware, it hasn't. Okay, so it's a new thing. A couple of other things to point out on the surface is we have these chiseled haunches, which we'd like to be polished in contrast to the brushed finish surfaces on the rest of the body. Same goes for this part of the crown guard as well. They'll also be polished. You'll be meeting our jeweler a little later on in the series, who will talk about that in some depth with you. He certainly knows more about the case finishing than I do. Another thing to point out, which might be interesting, is we're using a spring ball bezel ratchet. So that's what these little holes here are for. What you might see on a lot of micro brands is this kind of bezel ratchet. Nothing wrong with it, but to my ear anyway, and I have a couple of watches that use this, they're a little tinny when you turn them. I like more of a thunk when I turn my bezel. I'm going to show you quickly how these work, just as a point of interest more than anything. So the way a spring ball bezel ratchet works, instead of having this kind of flippy piece of aluminium, you have to bear in mind that when this was first done, it was done, and the technique is patented. So if you look, for example, at the original Submariner, I'm not going to go beyond I'm not going to go pre-Submariner and start talking about 50 fathoms and that kind of stuff. I just don't want to go there right now. But I'll say the original Submariner, not the original dive watch. Okay. What they've basically got is this little bit of wire that sits in this recess, and that's patented. Okay, so everybody else who came thereafter who wanted to achieve the same effect had to find ways round and loopholes for achieving the same effects but using a different method. Incidentally, talking about the springs, in order to get the right feel for the bezel, the thicker, the denser the spring, obviously the harder it is to work. So we experimented with maybe 4 or 5 different grades of spring to find the right clunk. Anyway, so you'll see underneath the bezel that we have these recesses. There's obviously 60 of them. 120 would mean smaller holes, smaller ball, less click, and more play, which is a big bone of contention for dive watch owners. Somehow the measure of quality of a dive watch is whether the bezel moves back slightly or not once you've clipped it into position. That's purely about fit and measurements. As an example, if our bearing was slightly smaller than the hole, that's where the play would come into it. I guess it is a mark of quality in the sense that if it's badly measured and there is a huge amount of space between the drill cavity and whatever's going in it, whether that's a bearing or whether that's a peg for a click ring, it's got to fit tight. So that's where that play comes in. Having this big chunky bezel is absolutely paramount to the aesthetic of the watch. It's extremely tall, as a lot of you will know, which gives that kind of soup bowl effect. There's a lot of depth between the top of the bezel and where the face actually is. That's intentional. I like, personally, my watches to appear deep. And when you put double domed sapphire on top of a watch that has a lot of space between the top of the bezel and the face, it looks even deeper. So you get this sort of, so you get this real cavernous kind of effect, and it makes the thing look really substantial when you look down on it. That's something I like. I don't know if everybody will go for that or not, but it's just, I guess when you're speccing your own product, then you just pick the stuff you like, right? And that's just something I really do. But as I say, yeah, this is a tall bezel. I mean, if we just inspect this, I can measure it from top to bottom. I'll have to zoom in so you can see the figures. You'll see that it is a 5.3 mil bezel, which is pretty tall. Actually, there's a manufacturing necessity for it to be quite tall as well. It was one of our ambitions to have highly detailed coin edge, even looking at possibilities of having it laser cut. That was the original plan, by the way, but there is a CNC tool in existence, which we didn't know at the time, which will allow us to cut this kind of detail. The reason you won't see it much on high volume production watches is the endpoints of the tool wear out really quickly, and we probably need to use one of these tools per every 10 or 15 bezels. So if you've got a huge volume production run, you're making thousands of watches, it's not just a case of the tool expense, but the fact someone's going to need to stand there and change them. It's not really viable. So those kind of details can only really be facilitated on a small run. Anyway, I realise that I keep moving away from talking about the details of the watch. Right, so let's start top down about spec. So one of the things we will not be manufacturing is the sapphire crystal. So from this elevation, you'll see that we have a double dome sapphire, and we will be applying a anti-reflective coating to the underside and not the top side. Another thing we won't be making ourselves are the gaskets, mainly for two reasons. I wouldn't know where to start. And our glass diameter is pretty standard in the sense that it's not wholly different from what's available in the market already. And we didn't want to produce a piece either that if something did go wrong in the future, or you wear it to death and you need to replace it at some point, that these parts were hard for you to get hold of. So I guess the next logical thing to do would be to actually put the bezel back so we can see it in context. We're opting for blasted ceramic. Nothing wrong with shiny bezels, love them, but I prefer the matte ones. And I think with the printed colours that we're going for on the surface, the matte finish just looks a lot more classy.